In this movie, we add the next step to our data model to demonstrate the create table statement, which in my eyes is adding of unique index keys or constraints to inversion key entries that are not foreign keys. An inversion key is like an alternative key inside a table that can be or should be unique. A little bit like implementing BCNF, but we're not going to actually separate the unique columns out into separate tables. All I'm going to do is I'm going to create a unique constraint. For instance, a category. Why would you need more than one category name? The reason why we use category IDs is they're actually called surrogate keys. They're called surrogate keys because they're used as a surrogate in place of what is the natural key, which in this case, it's the key that naturally describes the category table, which is the name of the category. The same would apply to the name of the act and the name of a country, and so on and so forth. There are a few other things in this script that I will introduce, but this is the first part, is essentially that I've gone and created unique keys as constraints which will generate keys internally, and I've given them names. Again, Oracle generates a unique index internally, so I've called it XUK because the constraint name will be copied to the index name by Oracle. So once again, I've still got the foreign keys. I'm just scrolling down to show you, for instance, here is the name of the venue, and we're going to go further down. We're going to find any other names that are relevant. There's obviously nothing on the supporting act table that is natural. There's nothing on the price table that's a natural key. There's nothing on the ticket. Ticket's just a seat number, which could possibly be a natural key, but you had multiple venues. So if you have multiple venues, they could have the same seat number, so you can't have a unique value. It basically applies to things like categories, acts, countries, states, cities. And there's one more thing that we've changed in here. I've actually modified the model a little bit. So I'm going to show you the modification before I show you the script. So I'm going to open up my events schema inside my data modeling tool. And if you can recall from the last version of this model, I've actually added 3 tables here. What we actually did was in the venue table, we had venue ID, then the name of the venue, then the name of the city, the name of the state, and the name of the country. Now, given that these are lookup items, they can quite conceivably be placed into separate tables, and you could have them as a country code accessed from the venue with a link between country and venue, and then city link to venue and state link to venue. You don't have to link them together, but you can, because states are contained within countries and cities are contained within states. I go back to my script. I find new entries for these tables, separate tables. Now I have to create the country first because the state and city rely on it. Obviously, state relies on country, city relies on state, so we create them in that order. If I were to drop them, I should technically drop them city first, state then country, or disable the foreign keys. And here's the venue. First of all, I've added city ID, state code, country ID. I've added foreign keys, all with the right constraint names, created the indexes, then I've gone back and created the country table. Again, I'm naming everything, keeping everything consistent. Consistency is really important within data modeling, because if you name everything the same, or you just stick to the same standards all the time, it's a lot easier for people to understand things. Now I'm going to go, it's not much point if, as something like a data modeler or an architect, you're continually explaining to people what things mean. It's a waste of your time and a waste of their time. So be clear, be succinct, and be consistent. And I'm going to cascade again. What I'm going to do is I'm going to create the user, and I'm just going to copy and paste. Once again, I've tested this, and I'm going to go down to here, and it's going to let me get to the end eventually. I'm going to go back to my Linux window. I don't see any errors. Doesn't mean there aren't any, so I should always check. And now I'm going to go back to here, connect in SQL Developer, go into the tables, and you should see that we have the city, the country, and the state table. And also, if we go somewhere such as the Act table, we will see that under Constraints, we now have a unique constraint called xActName. So that's unique keys on natural keys or non-foreign key inversion entries. It's known as an inversion entry in modeling terms because it's not the primary key, but it is a unique key as well. So it does uniquely identify each row, but it's not the primary key because we substituted the natural keys such as the act name with a surrogate or replacement key called act ID. I'm using technically what are actually object IDs inside my data model. This is common for modern relational databases. Typically the applications are written for custom environments using front-end languages like Java, which are object-oriented anyway. It's part of the reason why you use surrogates, but not necessarily always.